Welcome to the next video on topic D, which is multi-digit whole number addition. And basically, we always try to go back and review some strategies and things that the students learned in third grade, just to provide that foundation. And, since they haven't probably done a lot of these skills and strategies since last year at this time, we try to go back and do a little review. And so basically what we're doing is we are moving away from those special strategies for addition in third grade, a lot of the expanded form and different other different strategies that students have used in the past, and we really focus now on students developing fluency with the standard algorithm for addition. Of course, we know as adults, and that's basically the way that we learned growing up in elementary school, but now it's more about, the thinking behind it, the understanding. Why does this work? So that they do develop a deeper sense of fluency with those standard algorithms as they go into the upper grades. So starting out with the basic standard algorithm for addition, we always try to show multiple ways of thinking so that the students are able to move from that concrete pictorial representation to that more of that skill and fluency with the standard algorithm. So what we're going to do is we're going to kind of look at one particular problem, and this is going to be kind of just a procedural problem, not a word problem. We always move, kind of with the word problems and the procedural problems all intertwined within our lesson. But just for this video, I just want to kind of give you the basics of what the standard algorithm is and how it works and look at it in different ways. So if we have the problem 3,134 plus 2,493, and we want to solve this problem ultimately using the standard algorithm. But before we do that, when we start our lesson and we're modeling for the students, we always want to kind of start with a little more concrete representation, showing that mental thinking on paper. And so we always try to start out with our place value system and relating all that we do back to place value, because that's the foundation for numbers. That's where everything builds upon, is that place value system. So what we try to do is we say, okay, let's look at a picture of this. What would this actual problem really look like? And so since this number goes to the thousands, we're going to create our place value chart up to the thousands place. So we'd say this is our ones, our tens, our hundreds, and our thousands. And so we're actually going to use the dots, or if we did it under our Elmo, we would use the place value discs. But we're going to do the dots to represent the discs that also therefore represent digits or numbers. So if we have 3,134, we talk about, okay, so what is that? Well, that's 3,100, 3 tens, and 4 ones. So see how we use those little dots to represent those digits. And then we say we want to add more to that. So we're going to add the second number, which is 2,493. So if we represent this on our place value chart, we would say, okay, 2,400, 9 tens, and we've tried to move into placing them in groups of 5, so that also then 2 groups of 5 make a group of 10. So 5 in each row. That way it looks kind of like a 10 frame, something that they're used to from lower grades. And then, of course, 3 ones. And we say, okay, boys and girls, we want to add these together. And when we're thinking about introducing that standard algorithm for addition, we're talking about, that's adding in each place. That's finding the value in each place of the place value system. And so we're wanting to add our ones first, then our tens, and so on. And when we're doing that, sometimes we're going to have to regroup or rename that particular place because we have more than what we need that will fit in that place. So we'll get to that in just a second. So we'd say, okay, we're going to start with our ones. And so we would say, all right, if I have 4 ones and I want to add 3 ones to it, how many do we have? Well, we would say, oh, we have 7 ones. Very good. Now we're going to move to the tens place. If we have 3 tens and 9 tens, we would say, okay, And I'm sorry, I think I added too many 10s there. Let me back up. Sometimes when you're talking and writing at the same time, that happens. There we go, 9 10s now at this point. So we would say, okay, boys and girls, well, how can we put these together? And they would say, oh, well, 9 plus 3, that makes 12. And I would say, yes, you're right, that does make 12. But can we put this 12? Can we put 2 digits in one place? And they're like, no, we can't do that. And so we go through and we talk about, well, how can we rename these 12 10s? What is that the same as? And all of this is built off of that first topic, that we did in Module 1 about building those numbers. That's why we started with those discs and then moved to the digits and talked about, the renaming of numbers. Oh, well, 10 ones is the same thing as 1 10, and so on across the place value system. And so here is where that's going to come back into play. And, of course, we would say, all right, well, 12 10s. And somebody in the crowd is going to mention, oh, well, that's the same thing as 102 10s. Yes, very good, exactly. We know that we can bundle. We can move one of these 10s here to down here or just kind of bundle them together. And we know that 10 10s make 100. So we can bundle those, group them together, and move them over to the larger place to the left. Therefore, we say, okay, well, how many do we have now? And so we have 2 left, and then we moved that one group of 10 10s to make 100 to that hundreds place. So then we move to our hundreds, and we say, okay, we have 1 plus 4 plus 1 more, which makes 600. And then we would move to our thousands place and say, okay, we have 3,000 plus 2,000. That makes 5,000. And so we put our comma in, and we read this number as 5,627. So showing them that pictorial representation of why those group together and move to the next place, to that larger unit, and showing how 10 of one unit make one of the larger unit to the left, that's going to help them better understand when we're doing it the more efficient way with just the standard algorithm and no actual picture representation. So if we're going from the place value chart and then moving into the standard algorithm, just lining your numbers up vertically, we also talked about, well, if we were looking at this problem, what exactly would it look like? And we talked about using a pictorial representation of something called a tape diagram. And usually when we're doing the tape diagram, we like to do it more with word problems just because it helps them to pick out the important information and to understand how the numbers work in the problem. So we won't actually do the tape diagram for this, but doing it as a word problem, the parent helper tools through the Eureka website, those newsletters and things show you all about that tape diagram, and we may end up doing a lesson in the future, a video strictly on maybe a word problem with a tape diagram. But let's just go ahead and continue using the standard algorithm and show, and I usually leave both of these up there so the students can see from this pictorial representation, this concrete, moving a little more abstract to just digits, just numbers. So we would say, okay, remember, we always start in the ones place when we're adding. So we say, okay, we have 3 ones plus 4 ones, that's 7 ones. Then we move to the tens place, we have 9 10s plus 3 10s. And so they say, oh, that's 12 10s, Miss Kelly. And I try to use that unit form when we're adding because that helps them to think, okay, I'm not talking about 12 ones. It's not 9 ones plus 3 ones, 4 ones plus 1 1. We're moving to larger places, therefore the values of those digits change. So now we're in the tens. So we think, okay, well, if we have 12 10s, what is that the same as? And they say, oh, well, that's 10 of those 10s. That makes 100. So that's why we move to the next place with that 1 or the group of 10 that makes 100. And so we put our 1 on the line and then write the remaining 10s that we have. Sorry about that. And this way, with writing the regrouping close together and putting it on that line, that helps them to see, oh, there's my 12 10s I was talking about. In the past, you know, we showed the students to write it up here, but a lot of times that regrouping kind of gets lost. They forget to add it, that kind of thing. So when we're putting it at the bottom, they remember, oh, that's the last thing I need to add right there. Or sometimes they'll, you know, make combinations of the numbers, and which is fine. So then we move to the hundreds place. So we have 4 plus 1 is 5, plus the 1 that we regrouped makes 6. And then we move to our thousands. 3 thousands plus 2 thousands makes 5 thousands. And so we compare the two values that we got as our answer and say, and see how obviously they are exactly the same. So our ultimate goal is for students to be able to move to more of the abstract, that more efficient way to add with the standard algorithm. And really, up until this point, educationally, this is just now becoming more developmentally appropriate for students, just because they've got to have all of that number sense and that understanding behind why these numbers work, how they fit together, before they can apply it to even larger numbers when they're adding together. So this basically kind of gives us an introduction of adding using the standard algorithm in grade 4, and that concludes our video.